So we had two super interesting papers about AI as a general within science and engineering, invention of a method of inventing, and another really interesting paper about commercial uses of AIs. And this caused the organizers to encourage me to leap immediately past the papers to the thing everybody wants to hear, which is me as well as Manuel says, yes, it's GPT, go ahead and drink the Kool-Aid. And I am actually going to leap to that, so Catherine, keep me current on mine, but I want to talk about the papers a little bit first. Let me start with Daniel's paper. There's some things in this paper you could disagree with, but they just really aren't very important. That's the first thing I wanted to say. Right, the TensorFlow launch. It could either be itself, or it could be a pretty good date for before and after. And I think it's just not worth arguing with him about that. Both interpretations are really interesting. He did a lot of work on the skills to create these firm-level engineering task levels. He also created a measure of firm-level tasks outside engineering functions that might be automatable. Suitability for machine learning. Both really interesting things to do. The other thing that's in there, and here I think I'm going to disagree with Diego a little bit, that, I'm not sure, a thing to like about this paper is that the causal inference, hire more engineers and you'll have more valuable firm, is enthusiastically rejected by the author, right? The engineers are correlated with slow-moving, unobserved assets, we call them assets, everything's an asset here, at the firm level, which is pretty consistent with the firm effects literature, right? We have firms that buy a lot of AIT skills before TensorFlow. They're super valuable already if they're at the very top of the distribution. We have the next two quintiles. By the way, the bottom two quintiles have 0 AIT skills. Right, so the top quintile is 20% of firms. The middle quintile is 5% of firms because ties in the integer number of AIT skills are so important. You can guess what tie that is. Right, so we have, now, what the shock did, it raised to firms with much AIT engineering talent. That sort of opens a really interesting box. What are these slow-moving, unobserved assets that are extremely heterogeneous at the firm level? They might be data. They might be deployment of data analytically in business processes. It didn't raise firms with much SML. Right, I mean, how's a valuation going on Wall Street going to see AI engineering potentially very exciting and more so over this period? Jobs that might get automated with AI? Yeah, at another firm 25 years from now. So that was sort of interesting. I'll note another really fast. So on the multi-author papers, I guessed wrong about who to label it on. John's talk, I think, was really interesting about this paper. Let me say a couple of really positive things about this paper, and then, like, what do you do if you're a happy discussant? What was not there that I would have liked to see, the more thing. I mean, one thing is, like, this ground truth idea, this looks like a modeling shortcut, but there's actually, think about what G might be. G might be, this compound kills the cancerous cells rapidly and the rest of the organization slowly. Right? G can be an extremely complex object, right? And lots of science and engineering search is for very complex solution definitions. That I thought was a really artful thing. What are the important limitations? This B is one number, right? So they can't do the exercise Gustavo did yesterday of, because everything's either a high B or a low B. So they can't do that interesting exercise Gustavo did yesterday of what is it good at? How is it different from science? How is it different from maps, right? We now have Abhishek Nagaraj, really interesting thesis about maps, literal maps. And then there's the metaphor of science as a map. It's a valuation model. These two papers have in common that they're both valuation models. What else this is a paper about one search, right? The value in one search. So we don't, you might think the different kinds of accumulation of knowledge across multiple searches have different features, right? Science sort of brought us to the dance, right, over the last many centuries. Science has a particular vision of what accumulated knowledge is publicly available and pre-commercial, and what other accumulated knowledge is proprietary to the firm. Machine learning has a different view of that. The other thing is, what recombinatorial things is this? It's the ones we see a lot of, right? It's not the one-off recombination that launches a whole new technological direction, right? You have all these people sitting around talking about we need to make a programmable computer, and they're down at the bottom of the organization is poor Eckert, and he says, I got to be able to store a digital bit, right? So Eckert figuring out that you could store a digital bit using a technology from radar, which he'd been involved in the invention of the previous month, that's not like this, right? That's about the breadth of, that's much more about Ben Jones and all that and the problem of the breadth of knowledge. So this is about the routinization of routine science and engineering, I would say, which Juan's paper sort of is too, I think. Okay, so now I'm going to leap to my other task. I tried to think of all the GPTs that have emerged in the past and created a lot of value, which one is most like the AITs today? And let me say, there are two really important things that are big breakout technologies from AIT into the commercial realm. One of them is customer product matching engines. Google, Facebook, Amazon, Netflix, Uber. The Uber one is simpler for that. And the other one is user interfaces. If the user interfaces were the ones that were generating a lot of excitement in the rest of the commercial world for, it's a breakthrough access technology, I would have picked a PC as an example of an earlier GPT. But it's the consumer product matching engines that are generating enormous excitement in the rest of the business world. So I'm going to pick the computer. So the computer, the computer circa the late 40s and early 50s, very much like Coburn, Henderson, Stern, right? It comes out of this weird astronomy, physics, ballistics triad, and it spreads to basically all of science and engineering really fast. Why is that? Every scientist and engineer can see why it's valuable to calculate, right? Really easy to see. Same thing with AI, I would argue, and the science and engineering applications we just heard about, right? There's lots of, we, in our own scientific work, know when we want to predict. So do lots of other guys. If that's all that ever happened, that would have been a very valuable technology. Computing would have been a very valuable technology. It would not have been the growth driver of the late 20th century in the rich countries, right? It was the breakout from computing to business data processing that involved lots of new complementary invention that did it, right? And here, you know, a GPT feedback loop, you got to think about the simple analytics of a feedback loop generally. There's two phases. Once a feedback loop is going, hey, this is like the best thing for aggregate payoffs that you can possibly happen. Before a positive feedback loop gets started, it's kind of the opposite, right? The basic welfare economics of a going positive feedback loop are extremely positive. The basic welfare economics of a yet to be started positive feedback loop are extremely negative. So what kinds of new inventions did it take to break computing out of the science and engineering narrow domain of utility, right? And there were two. There were recombinant invention of complements, storage devices, tape, disk drive, they're already cards, I/O devices, printers, card readers. Computing, very unimportant, actually, for a long time in business data processing. They called it computing, but they meant storage. Breakthrough inventions on the application side, which I will argue in a second, just like the breakthrough inventions in the use of AIT commercially, were extremely incremental, right? The big one, the invention of the digital style of management, to use Jim Cortada's term from his history of the uses of computing, commercial ones. The invention of the digital style of management came in life insurance companies. And the breakthrough thing was life insurance premium building, which was already business data processing. It just wasn't electronic. It was done with card readers and card sorters. But that opened the door. You know, that sold 2,500 computers. That's a lot of, that was a lot compared to the scientists and engineers. Then, after the automation viewpoint, which was so important to the life insurance guys, and about which they were totally wrong, they didn't get any labor savings. Their digital style of management also met a stateside, and then we were off to the races. Where are we now with AIT? Okay, absolutely. Science, engineering, related stuff where prediction is a word where you can see it, that's taken off really fast. That's not gonna be AIT ate software, which previously ate the economy. There are two candidates to be our premium building, right? They're the consumer product matching engines at the internet giants. And those are behind the one of the two really powerful directions of diffusion of AIT into the corporate sector before. You know, you could have a customer care app that's personalized a little bit, that's targeted a little bit, that's individualized a little bit. That's a lot like what Google and Facebook do, and you can do it right here in your own company, right? That's if you look at the surveys of intent to use AI in the corporate world, that's the biggest one. The second biggest topic is, how do I keep my boss from being so excited about automation? Because I don't want to get fired 6 months from now. And then the third one is decision support. Right, again, and what do the customer care and the decision support have in common? You can slide them into an existing organization. It gets things going, it's incremental, and it might have high value. So I would say, using this not crazy historical analog, yeah, I mean, we might be about to break out into the big money. There'll be a period of fairly incremental and narrow cast exploration and building at the firm level, but it could really happen.